Okay, so this is a different concept. I know that we're still in chapter 5, but we're moving away from quadratics and we're looking at rational expressions. So rational expression, just think of this as fractions. These are fractional expressions. And so we have fractions like this, 8 over 3, but now we're putting our variables in here. And so we've got variables in here and we're going to create fractional expressions. So this first question says, we all know that fractions will simplify. But why? So what happens is we have this fraction of 24/9, and we know this simplifies to 8 over 3. So what we want to do when we're dealing with rational expressions is we want to turn these fractions into common factors. Now, what we've been doing with factors is we've been doing things like this, right? Where we've got some factor and we do trial by error or difference of squares, or we do something and we come up with these factors. But we also know that we can use a GCF and we can do something like a number and just one factor. And what we've pulled out is this factor of 3, right? So if we have x plus 6 on the inside, the greatest common factor, so this is the key word right here, factor, is 3, and that's what we pulled out. So if we look at this fraction, 24 over 9, and we look at all of the factors of 24, we can say we have 1 in 24, 2 in 12, 3 in 8, and 4 in 6. Well, if we look at the factors of 9, we only have 2 of those. We have 1 and 9, and we have 3 and 3. So when we're dealing with rational expressions, we want to look and see where do we have like factors. So in this case, what we did when we factored back in Unit 4 is we had to look at our inside and our outside, our O and our I of FOIL, to see if we would get that middle term. But what we're looking for here is where do I have a common factor? I have no 9 up here, but I do have a 3. So these would be my 2 common factors. So my numerator would simplify into 3 times 8, and my denominator would simplify into 3 times 3. And so now that we're multiplying, we would say that our 3's cancel, and what we're left with is 8 over 3. And we knew that. And a lot of times what happens is we have 24 over 9, and we say divide by 3 and divide by 3, and this gives us 8 over 3. But when we do that, this is our greatest common factor. And so for us to be able to cancel factors out in a rational expression, I want you to think about it like this. I'm going to have 2 factors, and the key to this, and this is what's important, is you must multiply factors to cancel. Because I'm multiplying 3 times 8, and 3 times 3, these factors can cancel because I'm multiplying. So what that means is if this was 3 plus 8 and 3 plus 3, this right here is not multiplication. Okay, so this would be an example of how it would not factor. So this little section here says, which of the following illustrates this principle? And this principle here is that we have factors that cancel. That's the principle that it's asking us to validate. Okay, so if I look at this, I have 3 times x plus 1 and 3 times y minus 2. So a couple things I know. I am multiplying, so I do have multiplication, and I have a common factor. And my common factor here is 3. So my 3's cancel. So yes, this illustrates this principle of being able to cancel factors. Here, I have no multiplication. And so I have no common factors. So I know we look at this and we say, okay, well, there's a 3 and a 3, but they're not multiplied together, so this does not illustrate. There's nothing that simplifies here. Now, here I have 2 factors that are multiplied together, and this is how we recently saw it in Unit 4, because we have 2 factors. If we FOIL this out, so we reverse FOIL to get our factors, and we see that the top one here and the bottom one here are the same. So yes, I had like factors that cancel. Now, this is a tricky one. So what happens is I have 3x times 1. So here I multiply, but I've got this plus 2 on the end. So because I have this addition statement, this is not multiplication. Part of it's multiplication, but the whole thing has to be multiplication, right? Here I have two factors multiplied together. Here I have a common factor multiplied in, but this does not count. So this is not multiplication. So this does not demonstrate canceling factors. All right. So the key here is that we never, never, never cancel terms. You can only cancel factors. And I'm gonna give you an example of what this looks like. 3 plus x over 3 plus y. These are all terms. Now, this is different than factors. 3x plus 3 over 3 y plus 4. Here I have factors, and my factors are these 3's because they're multiplied in. It doesn't matter that there's addition here because I could distribute this all the way through. So it's super tricky to be able to see, okay, where do I have a factor and where is it just a term? All right, so let's practice this a little bit. So if we look at something like this, everything is multiplied together. So this is all multiplication. So if it's all multiplication, then we can start canceling things. So we want to look at this. We've done this before. We did this when we did exponents. So we have a 3 in the top and a 12 in the bottom. So here we're really dividing. So we end up with a 4 in the denominator. 3 divided by 3, 12 divided by 3 gives us a 4. Now I have 2 x's in the top and 1 x in the bottom. That means I have more in the top. My exponent rules say I would subtract. So I have 1 x in the top. Here I have 1 y in the top, 2 y's in the bottom. So I have more y's in the bottom, and that's where that y stays. So this is what that would look like simplified. Okay, so here, this is not multiplication. So I want to see if I can turn it into multiplication. And to do this, I want to find a GCF. So up on the top, I can factor out a 3. So if I pull out a 3, I'm left with 2 minus k. All right. Now in the bottom, this is a difference of squares. So I have k plus 2, k minus 2. So I'm going to rewrite this numerator, and I'm going to say 3 minus k plus 2 over k plus 2, k minus 2. Now, what you see here is that this is a negative k, and this is not a negative k. These do not cancel in this form. But what I can do is I can take all of this and I can factor out a GCF of negative 1. So if I pull out a negative 1, now I have negative 1 times 3, and then I would have k minus 2 on the top. So if I pull out this negative 1, if I distribute the negative back in, I would have negative k, which is what I have. Negative times negative is positive 2. Now on the bottom, I would have k plus 2, k minus 2. Now, everything is multiplied together. So we went from two expressions that are all 4 terms. Nothing's multiplied together, so I can't cancel anything. I can't cancel this k with this k. That doesn't work. And now it's all multiplied on the top and all multiplied on the bottom. And what we did is we factored out this negative 1 so that this factor is the same as this factor, and it cancels. So my final answer here is negative 3, because I have negative 1 times 3 over k plus 2. All right. Now, with this next one, we see on the top that we're going to have to do trial and error. So I'm going to have 2p and 1p, and my factors here are going to be 1 and 4 or 2 and 2. So this would give me, this one's not going to work. So if I want 7, this is going to be 8 and 1, and I want a positive 7. So it's going to look like that. On the bottom, it's not trial by error, but it is a common factor. So I see I can pull a 5 out, but I can also pull a p out. So I'm going to factor out a 5p, and I'm left with p plus 4. Okay, so I went from all adding and subtracting to now multiplying. So now I can cancel, And I see p plus 4 and p plus 4 are going to go away. So I'm left with 2p minus 1 over 5p. All right, okay, let's see what else we have going on over here. Oh, okay, so now we're going to multiply. So if we multiply, we are not doing the butterfly. So multiply fractions, we are, when we simplify, you cannot butterfly. The butterfly technique works when we have an equal sign. So the butterfly only works when we have an equal sign. So if you have a fraction equals a fraction, then you can butterfly. Over here, there's no equal sign. So butterfly only works when solving. And we know that when we solve, we have to have an equal sign. Okay? But what I can do on this, even though I can't butterfly, I can cross reduce. And when I cross reduce, that just makes my number smaller. So if I look at this, I have a 7 and a 14. So I can divide 7 by 7 and 14 by 7. This becomes a 2. I can do the same thing with my 5s. So I have this becomes a 5 and this becomes a 3. All right, so let me rewrite this. I'm going to just look at my numbers. So I have 3a squared times 1 over 2a. 2 times a is 2a. So you see I have a's on the top and a's in the bottom, so I can keep going, and I would have 3a over 2. And that would be my final answer. Now, what's important when you do this is don't get this all crusty up here so that you can't see what you have left. So that's why all I did was reduce out my variables first. The other thing is, if you're not using a calculator on this, it would be crazy to do 15 times 7 and 14 times 5 and then try to find a common factor and reduce it. Just cross reduce. It makes it so much easier. Okay? Now, this is not pretty because I can't reduce because I don't have like factors. I'm adding and subtracting on all of this. So I'm going to factor out everything and then see what I end up with. So on the top, I factor out a 5 and I have x minus 3. On the bottom, I can factor out a 3 and I have x plus 3. And what I would tell you is always go back through and distribute this in your brain and make sure it works. So 5 times x is 5x, 5 times negative 3 is negative 15. We get down here, 3 times x is 3x, 3 times 3 is 9. So I'm good. So now I go over here, factor out a 4, and I have x plus 3. So 4x, yep, plus 12, yep. Go down to the bottom, and I'm going to factor out a 6, and this is going to give me x minus 3. 6x minus 18. Okay? So if I look at my numbers, 5 and 6 don't cross-reduce, 3 and 4 don't cross-reduce. So then I look at it vertically. 5 and 3 don't reduce, but 4 and 6 do. So this 4 can become a 2, and this 6 can become a 3. Okay, now I'm going to look at my factors here. So remember, I can cross-reduce. So I have x plus 3, x plus 3, x minus 3, x minus 3. So all of those terms with x's all cancel out. And what I end up with is 5 times 2, which is 10 on the top, and 3 times 3, which is 9 on the bottom. So that whole thing is going to reduce down to 10/9. Okay, go ahead and pause the video and do number 6 by yourself. Okay, so here's what we have. We have difference of squares, and then just a factor. So x plus 5 and x plus 5 can cancel because they're on top of each other. So far everything's been canceling across, cross-reducing. But when they're on top of each other, we can cancel those out too. So 2 goes into 5. So what I ended up with, I rewrote it, and I have 5 times x minus 5 over 5 minus x. Now, x minus 5 and 5 minus x are not the same. This has a negative 5 and a positive x. This has a positive 5 and a negative x. So I had to factor out a negative 1. When I factor out a negative 1, then these cancel, and I end up with 5 over negative 1, which is just negative 5. Okay? Now, this says divide the fractions, but really when we're dividing the fractions, we just have one extra step, and that's we're going to keep, change, flip. And we're going to turn this into a multiplication problem. So here's what I have. I have 2 minus t over 8 times, I'm going to flip it, 6 over t minus 2. Okay? Now, hopefully what you see is the order here is reversed. Negative t, positive t. So I'm going to do the same thing I did in the last question, is I'm going to take this factor and I'm going to factor out a negative 1. So now this becomes negative t plus 2. So now those two factors cancel. So this gives me 6 over negative 8, and that reduces to 3 over negative 4, or you can write it as negative 3 over 4. Either one of those would be okay. All right, now I'm going to do this in 2 steps. I'm going to factor and I'm going to flip, keep, change, flip, all in the same step. So if I look at this first factor, I would have 2x and x, and my numbers are going to be 1. This is a negative 1, so this is positive, and this is negative. If I check it, I have negative 2x plus 1, which gives me negative x. Okay? I look at this down here, and I would have 2x and x, and I want 6. But I'm going to be adding this, so because they're the same term. So if I do that, I would have, oh, that doesn't factor, does it? This is 3 and 1, which is 7, and this would be, oh, it does work, 3 and 1, which is 5. So plus, plus. Okay, so 2 plus 3 is 5x. Okay, so now I'm going to flip this. So if I factor the top, I'm going to have 2x and x. I want a positive, so this is going to be plus 3 minus 1. So if I test this, I have 3x minus 2x, which is positive 1. And then the denominator, I've got a perfect square, so I have 2x plus 1 and 2x minus 1. All right, so what can I cross reduce? This one goes with this one. This one goes with this one. And it looks like that's it. So these are different signs, so that doesn't happen. These are different signs, so that doesn't happen. And this doesn't happen with anything. So watch how I'm going to write this. X minus 1 squared, because I have 2 of them, over x plus 1, 2x minus 1. So that still looks a little sloppy, but it simplifies. So we did the operation, which was division, and this is what we end up with. Okay, so this last one that's super busy, go ahead and try this, pause the video, try it, and then come back and check your answer. Okay, so this one was kind of fun. So what we see when we cross reduce is x plus 2, x plus 2, and then x plus 4, x plus 4, and then these two x plus 1s are on top of each other, so those reduce, and so here's what I'm left with. Okay? All right, let's look at these. These are super fun, and I know that they look scary, but they're not. So the first step on this is we're going to rewrite this as old school division. And here's what this means. I have 10 over x minus 3. This division line says it's going to be divided by 5 over 2x minus 6. Well, guess what, guys? This is what we just did. So now I'm going to keep, change, flip. Now, when I flip this, I went ahead and pulled out my greatest common factor. And here's what we see. This cancels and this reduces. So this whole thing becomes 4. All right, this next one, it looks tricky, right? X squared minus 100 over x minus 3, divide, so old school, 10 minus x over x squared plus 7x minus 21. All right, I'm going to pause this. You do the same. You go work it and come back. This is the last question. All right, sorry guys, that was kind of a yucky one because this doesn't factor. So because this doesn't factor right here, you leave it. I mean, there's nothing we can do. We can just leave it. And so, and then with the denominator, for these two to cancel, we have to factor out a -1. So we factor out the -1, and we end up with two factors that are going to cancel. So when we combine everything, I can't cross reduce right here. And so this is what it looks like when I have it all factored out. Okay?